Alright, so today we're going to talk about multiplying polynomials. When you multiply polynomials, you need to remember your product rules and your product rules of exponents. For example, when I have 3x to the 7th times 6x to the 7th, what you do, since it's an all multiplication problem, you multiply your whole numbers first. What's 3 times 6? 18. And then your x, and remember you add your exponents when you're multiplying. So what's 7 plus 7? 14. So let's take a look at this next problem. I didn't mean to write it that high. Negative 5x to the 3rd power times negative 6x to the 9th power. We multiply our whole numbers first. Well, our integers. What's negative 5 times negative 6? It's a positive 30. And we add our exponents since our bases are the same. 9 plus 3 is 12. And that's your answer. Now, when you have a monomial times a binomial, it's just like the distributive property, where this has to be multiplied times this, and this has to be multiplied by this. Same thing applies. We only look at our whole numbers. What's 8 times 3? 24. And then what's x times x? Remember, there's an exponent of a 1 and a 1. 1 plus 1 would be 2. Plus, what's 8x times 5? Well, what's 8 times 5? 40. There's no x there, so that x just stays. It can be kind of tricky when you have a negative in front. So let's do a monomial times a trinomial. So we do negative 3 times 1, because there's a 1 in front of that. And we add our exponents. Remember, there's a 1 here. 2 plus 1 is 3. What's negative 3 times a positive 2? Negative 6. 1 and 1 is 2. And what's a negative 3 times a negative 4? Positive 12. And then you bring the x down. So let's do a binomial times a binomial. This is just doing distributive property twice. You take this number times both of these, and then you take this number times both of these. And you'll notice that these are both exactly the same. If this right here and this right here is this part, and this here is this part. Now we distribute our 2x. 2 times 3 is 6. X times x is x squared. Plus 2 times 4 is 8. The x comes down. Plus 7 times 3 is 21. The x comes down. Plus 7 times 4 is 28. Now you always want to see if you can combine like terms in this problem. I don't have any other x squareds and I don't have any other whole numbers, but I do have an 8x and a 21x that I can actually combine to make 6x squared plus 29x plus 28. And that's your final answer. Sometimes you'll see them that look like this, where you have a binomial times a trinomial. We do the exact same thing we did up here. I do 9x times this whole thing, and then I do plus 4 times this whole thing. So now let's distribute. What's 9 times 3? 27x. 1 plus 2 is 3. Plus 9 times 8 is 72. X times x is x squared. Plus 9 times 9 is 81. X comes down. Plus 4 times 3 is 12. X squared. Plus 4 times 8 is 32. X. Plus 4 times 9 is 36. Now we combine like terms. I have no other x cubed, so I have 27x cubed. I have a 72x squared and a 12x squared, which is 84x squared. Then I have an 81x and a 32x, and that makes 113x. And then I bring down my remainder plus 36. So it's not that hard, it's just trying to remember it. Now, a lot of times you'll see use FOIL to multiply. Now, it doesn't matter how you do it, you will get the same answer each time. FOIL stands for first, outside, inside, last, which is first numbers, outside, inside, last. And that's how I learned it. However, the word FOIL always freaked me out. I really like this method where I take this times the whole thing, and then this times the whole thing. Just because I won't make a mistake with my negatives. A lot of times if there's a negative here or a negative here, you can make mistakes with your negatives and it can get kind of confusing. And like I said, the word FOIL always freaked me out. It does not matter how you do your problems. As long as you start with the right problem and you end with the same answer, it doesn't matter how you get there. So this would be x times x, which is x squared, plus x times 3, which is 3x, plus 2 times x, which is 2x, plus 2 times 3, which is 6. These two in the middle can add, and I'm done. Now, you may see some that look like this. And this freaks a lot of people out. Remember that power means you have two of them. This is actually written as x plus 5 times x plus 5. So that's x times x plus 5 plus 5 times x plus 5. So we have x squared plus 5x plus 5x plus 25, which gives me this. A lot of people will just do x squared plus 25. It doesn't work that way. You've got a middle term in there, so you've got to remember that. The only time you won't have a middle term is when you have a problem that looks like this. The first and the second, they look almost the same, but one's a minus and one's a plus. So if we multiply this out, this times it, now that's a minus. So now here I have a times a, which is a squared, plus a times 2, which is 2a, minus 2 times a, minus 4. This has actually canceled out. And that's your answer. This only will happen if these are exactly the same and one's a minus and one's a plus. So you just have to be really careful. The last one I'm going to talk to you about is if you have something like this. That just means k plus 4 times k plus 4 times k plus 4. And when you're typing your answers in, make sure you use the correct variable. You want to do these two first, okay? So I have k times k plus 4 plus 4 times k plus 4. Do this whole problem, k squared plus 4k plus 4k plus 16, k squared plus 8k plus 16 times k plus 4. Now, since this is a multiplication problem, it doesn't matter how you write this. So I'm going to actually write my k plus 4 in front so that I have less to do. So then, once again, I do k times everything and plus 4 times everything. Now I multiply. K times k squared is k cubed plus 8k squared plus 16k plus 4k squared plus 32k plus 4 times 16 is 64. I'm sorry, I'm running out of room. So now we combine like terms. I only have a k cubed, 8k squared, and 4k squared is 12k squared. 16k plus 32k is 48k, and then plus 64 is left over. Now, to be perfectly honest, it doesn't matter if you rewrite it or not, you're going to get the same answer. All right, so that's multiplying polynomials.